voice come through the microphone? Okay? Okay. So in the past I haven't used a microphone, but as I get older it seems like I need more help. So I'm going to try that this semester and see how it goes. If you have any difficulty hearing me, let me know and I'll try to improve. Just don't ask me to sing, because I cannot. My previous partner who did this with me is now retired, Professor Nelson, has a really good singing voice. And so, because you came after retired, you all are shorted that opportunity. What I want to do is first give a overview of what the course is about, and give you a brief summary of what to expect in lab, and especially for this week. And then we have some administrative things to take care of. So this particular presentation is available on Canvas in case you missed some things, so you don't feel like you have to scribble everything down. We'll talk a little bit more about where to find the presentations on a week-to-week basis when I go to the Canvas website a little bit later. Okay, so that's who I am. I'm John Hung. My office is Brown 227 in the corner over here by the stairwell near Miss Elizabeth Gowan's office. That's my email address, my AU email address. I'm generally here from Monday through Friday from 8 in the morning to 6 at night. I teach, however, usually Monday, Wednesday, Fridays in the morning, so if you want to catch me, afternoons I'm usually around. If you want to send me a note and say, hey, can I meet on Tuesday at such and such time and make an appointment, I'm fairly good at remembering those. Okay, I will confess that I have forgotten on occasion. It's not because I don't like you, it's just because I'm just going to pull the professor card. We're absent-minded. Let me introduce the GTAs. What you see here is a chart. Tuesday, Wednesday, Thursday is when we have the actual lab. So we have a meeting every Monday with me. And the GTAs generally try to come here also just to correct anything that I said incorrectly. And then during the week, Tuesday, Wednesday, or Thursday, you will be with one of the GTAs, one of the TAs in lab. So we have Tuesday sections. We have two sections, one at 12:30, one at 3:30. Wednesday we have a section at 3, and on Thursday again we have two sections again. And so the TAs are there. Let me go ahead and introduce them. I'll start off with the most senior guy, Dalen. Dalen should actually be smiling more because he's one of our fine GTAs here. He's doing great. He's going to be a dad soon. October, is that right?
Yes, sir.
Yeah, so he should be smiling more. maybe the way to fatherhood is upon him. So if he's not smiling today, it's just maybe hasn't sunk yet. Joey, I'm missing Joey, but Joey is covering 3 of the sections. Sections 2, 3, and 4. All right, Joey Hines is also a graduate student. And then we have another person, Graham. Please have a second. Graham is very experienced in this lab, has taught it before. And I think all 3 of you have a computer engineering background, is that right?
I'm electrical.
You're electrical. He's electrical without your computer engineering background. So if you're in this class, you are either taking 3040 because you're an electrical engineer, which means you took a prerequisite class, 3030, the radio lab with Dr. Wentworth. If you had not had 3030 and you're an electrical engineer, you need to go get special dispensation for Dr. Wentworth to be in here. Okay? I don't grant that permission. That's a Dr. Wentworth issue, so that's a prerequisite. I'm not going to ask you to sign anything, blog, or anything like that, but you need to have that prerequisite class. If you're a computer engineer, you don't take 3030, the radio lab. I think the prerequisite class is 2220.
That's computer systems.
Computer systems. Okay. So I'm going to ask you to be a good Boy Scout and say, yes, I've taken the prerequisite class. If you have not had the prerequisite class and have concerns, come and see me. Again, I can't solve prerequisite issues. We'll walk to Dr. Wentworth's office together and we'll see if we can solve that.
My section's the wrong time.
Your section's the wrong time.
Yep.
Okay, Tuesday, section 5 is not at 3:30, it's 12:30. It's in the right place on the chart. The date is wrong. I'll fix that. Okay. It should be the same time as Thursday. It should be 12:30. Okay? Now you know why the TAs come. They fix errors. Okay, so let me tell you a little bit about the technical objective, what will happen by the end of this semester. By the end of the semester, you'll get all these things that you see on the screen working together. You're going to integrate some things together, both in hardware and in software, and basically create, sometimes in computer engineering, we're going to call it an embedded system. You're going to put intelligence into something. For the electrical engineers, we just call this an electrical engineering system design lab. So all these things are going to come together. So you see here a motor up here in the upper right-hand corner. Okay, it's a little DC motor. You're going to have to build an amplifier during the term. I've indicated that with a picture of a transistor symbol and a transistor there. So an amplifier will have to be built to drive that. A motor, we call that a motor drive. You're going to control this motor. You're going to, by the end of the semester, control the speed of that motor by using a microcontroller board. It's an evaluation board. We call it the discovery board. It's just an evaluation board for looking at the ARM microcontroller. That's that green board in the middle there. There are actually two microcontrollers on that board. One of them is just tasked primarily with interfacing to your computer that you're going to use for designing your C programs and stuff like that. And the other microcontroller is the one that's doing the actual work. So basically, we're going to embed, in a sense, this intelligence into the motor system and use that intelligent device to control the speed of the motor. And then you're going to also interface that microcontroller to a keypad, which you see over on the left-hand side. And the keypad will be used to select what speed you want. I want speed 0, 1, 2, 3, and so forth. So during the semester, we're going to look at various different subsystems of the overall system. One week we'll look at reviewing how to do a digital I/O, for example. Another week we may be looking at how to respond to button presses as an interrupt. Okay? Because this is a control system and we need to be controlling the motor on a regular basis, issuing commands, we will be learning how to use timers. Okay? As an example, every week there will be a little part of the overall system that you and your teammates will explore. And then toward the end of the semester, you'll get a couple of weeks to kind of pull it all together, and hopefully it will work for you. All that work is done on a breadboard, which you see over in the lower right-hand corner. That is called the EE board, it's called the electrical or something electrical explorer board, or EE board. When we say EE board, we're referring to this breadboard here. This breadboard here is actually a little bit more than a breadboard. It has some electronics underneath it, which provides some other functionality which are useful in this course. So overall, the technical objective is to do a system design involving both hardware and software. You also do experiments. You'll collect data. Collect that data, and then you're going to come up with some conclusions. Is this thing working well or not well? Okay, so that's some of the technical objectives. But doing well technically does not ensure that you're going to get the grade that you want at the end of the semester. So this slide shows how the course grading is broken down. On this side, on the left-hand side, for the most part, these are things evaluated by the TA. Okay? A lot of technical performance stuff. On a week-to-week basis, they're observing your work, they're checking off your progress. For the most part, the TAs are going to assess those things. There are a few things on the left-hand side that are not assessed by the TA, and they're in footnotes there. For example, I also make an assessment about the progress, and I do that by reading progress memos that periodically come to me from you. So your team will write some status memos like, well, the last 2 weeks we were supposed to try to do this, and it worked great. Or we're about there, we're about 80% there, but we need about a little bit more. So I make some sort of judgment about the progress. So that's called overall progress from memos. That's a grade that comes from me. Teamwork, the teamwork evaluation comes from several sources. The TAs kind of observe whether you and your teammates are getting along. You make a self-evaluation, and your teammate also kind of makes an evaluation. And we've learned over the years that everybody seems to like each other a lot, and they always say, my teammate can walk on water, and so that's almost a useless evaluation, and so that's why it only counts for 5% of the grade. Okay? That's not to say that we don't ever have friction. Occasionally there is friction, but come see me if there's friction. Okay? The design system performance, that's 20% of the grade. That's the technical part. Toward the end of the semester, you'll be able to see, oh, these are the goals that we're trying to achieve with our design system. We want motor speed to go from here to there in a certain amount of time. We want it to be able to maintain the speed even if we load it down. We want to be able to have 10 different speeds. We want, so on and so forth. All these technical things go into the system performance. And so that accounts for part of the grade. But you see, all of that is only half the grade. Okay? So it's very common in this class where some student says, I got my system to work, how come I got a B in the class? Well, it's because on the right-hand side, there was an issue. And you see on the right-hand side, that's all materials that essentially are, for the most part, evaluated by me. Okay? And you'll see that they're all related to communications, whether it's an oral communication or written communication. Okay, in my own personal professional experience and that of our industrial advisory board and people who hire you, they consistently tell us that communication skills are just as important as good technical skills. They come to Auburn to hire you because they know you're a good engineer, but they also expect that you are a good communicator. Not only delivering information, but also in absorbing information. So you see there's a bunch of assignments there. I mentioned the progress memos. I grade those. There is a midterm written report that you first write a draft. I'll give you some feedback. About 2 or 3 weeks later, you'll turn it back. I'll grade it again. Okay, so that's why you get 10% for the draft, 10% for the final. And then there's a final oral presentation the last week of the semester. And you'll see there's a footnote there. That's evaluated by multiple people. Myself and the TA do the evaluation. Okay. So, roughly half the course is technical performance. Roughly half the course is communication skills. And so it is possible for a student to not get the system working as well as they would like. Maybe to get 9 speeds instead of 10, as an example. And they can still do very well in the course and make an A because they're doing well over here overall. And as I said, there have been multiple cases where students said, everything works. And I had to say, but your memos and your reports are awful. You write like a Chinese person. That's probably me thinking that's a racial joke, but because I'm Chinese, I feel like I get to make that joke. Any questions about grading? Okay, please understand, this is not a class where you're going to make an A just by getting the correct answer. Okay, you need to make the correct answer and also describe it well. Okay, here's a typical week for 30, 40, 30, 50. Monday lectures. Okay, give an overview of the technical issues. Some suggestions for how you might approach things in that week. Then you and your teammate immediately, maybe even before you came into class, need to be working on the goals of that week. So you'll go to, there's pre-lab preparation. Pre-lab preparation doesn't have to start after Monday. We're going to take a look at the course content in a minute in the Canvas. And basically it's going to be my goal to try to get all the material out there so you can look at it anytime you want. But at the very least, you should be doing some pre-lab preparation after this meeting on Monday. You want to start the weekend before, that's fantastic. I told the TAs, they need to be prepared well in advance of the week. Okay? So, pre-lab preparation means, here's my idea of how I think I'm going to solve this in lab. Okay? It may involve a circuit, it may involve some programming. Programming in this class will be in C, as opposed to assembly language programming. Because we are working with a microcontroller, but we're going to be using C, a high-level language. So you'll maybe have flowcharts saying this is what it is. Maybe have a draft program ready, a circuit. Some of the things could even be tested or simulated even before you walk into lab on Tuesday or Wednesday or Thursday. Then there's laboratory time. You go in, you pull out your laboratory notebook, you say, okay, this is what I got to type in, or this is what I've got to grab from my H drive, or I got my program ready. I'm just going to load it up, compile it, load it onto my microcontroller board, see if it works, do some testing, gather some data. Maybe I'll analyze that data later on, all right, go home. Okay? And then finally there are different types of reports that need to be done. So let me talk a little bit later about that documentation. What needs to be turned in every week varies. Okay, so we'll see that in a minute when we take a look at the calendar. Okay, let me talk a little bit about teamwork. I mentioned teams several times. You see here, these are the recommended compositions of teams. If we can couple an electrical engineering student with a computer engineering student, we found that benefits both people the most. Okay? The typical complaint from the electrical engineer is, man, I didn't know there was so much programming in this class. I'm an electrical engineer. And the computer engineer's complaint says, I didn't know I had to remember any of that circuit stuff. And because there's some circuits that have to be designed. And so the two can help each other if they're a team together. The reality is we tend to have more electrical engineers than computer engineers, so there's not enough good computer engineers to go around and share with everybody. So there are some teams that will have 2 electrical engineers. There should not be a situation where there are 2 computer engineers working together. However, with that being said, this is a chart of who's in what section. Right now, the day and the section time are listed in this first column on the left. If you're an electrical engineer, you are probably taking 3040. It says EE, you're one of those guys in this middle column. If you're a computer engineer, you're over here on the far right. As you can see, we have more electrical engineers than computer engineers. 39 right now and 20. Okay. That we'll probably have more. That's probably the highest number of computer engineers that we've had in a while, which is good. I'd like to see that. But you see, most of the sections. Let's take, for example, Tuesday at 12:30, which is Graham's section. 8 electrical engineers, 4 computer engineers. So that's 12 people, 6 teams. 4 of the teams are going to have a EE and a computer engineer, but 2 of the teams are going to have 2 double E's. Now you may say, oh, am I handicapped if my buddy is a double E? No, that really is not a big issue. We just feel like you get more out of the class experience if you are teamed with somebody who's a little bit outside your discipline. Now, you might see that Tuesday 3:30 we do have something which has not happened before. That particular section has more computer engineers than electrical engineers. Now, we can leave things just the way it is. If we leave things just the way they are, then my last statement there, I would have to give a little, say, okay, well, that section, this year, we're just going to have some guys teamed up, 2 computer engineers. We'll let them struggle with the circuit design. But I'm going to ask you voluntarily, and you get no brownie points, this is just voluntarily. If you're in the Tuesday section and you're a computer engineer, if one of you would consider moving to a different section, like maybe this section, or maybe earlier in the day, then that would put more computer engineers in these sections which have fewer. And that would mean one of the electrical engineers in maybe, say the Wednesday section or possibly the Tuesday section would move into the pair. We potentially could have a situation where we have 6 and 6. Okay? It would balance things a little bit better. That's my wish list. I don't always get what I wish, though. Okay? So if you're willing to do something like that, please see me at the end of class. I'm just asking, I think you will have a better experience, but this is not the end of the world if we leave things just the way they are. There is another thing you will notice. If I add 39 and 20 together, what do I get? An odd number. So what that means is somebody is not going to have a teammate. Wednesday. So we could kill 2 birds with 1 stone. one of those electrical engineers could move to Tuesday 3:30. Maybe two of them. I don't know. We could shuffle things around. So the reality is, eventually, no matter what, somebody's going to be left without a teammate. Okay, it shouldn't be a computer engineer. Okay, it ought to be an electrical engineer who's out there alone. This happens often. Okay, there are just as many semesters with odd number of students as there are with even number of students. The world is not always even. If you end up being teamed alone, with you and yourself, I hope you like your teammate. It's not always the case, though. I will be notified of it. I will be made aware of it. The grading policy will be adjusted. Obviously, you'll get a lot of points for teamwork. You will not have to do the work that your teammate was supposed to do. Like he or she was supposed to write some memos and stuff like that. Obviously, you don't have to take on that burden. So we'll make some adjustments. All right. This is not our first time on this rodeo, and so you can do this lab well alone. We think you have better experience with a teammate, but there are occasionally I've had semesters where a guy comes to me and says, I really need to work alone this semester. And it's not that he's antisocial. It's like his life circumstances, like he's working or something, and he finds it difficult to have time to get together with teammates. If you are one of those lone warriors in the Wednesday section, we will take care of it. Okay? Any questions up to this point? All right, let's come back to the overview. This week, you'll get to meet your teammates. Correct me if I'm wrong, they form teams themselves. You don't assign them, right?
Yeah, they just took over the one.
Yep. So, brush your teeth, comb back your hair, present yourself well to your potential teammate during your lab day, and share some information. This is some things that I recommend. Communication with your teammate is probably one of the most important attributes. Not only learning what your teammate is able to do in case he gets sick and vice versa. That's part of teamwork also. But make sure there's no misunderstanding about when you're going to meet, what's the best way to contact. Everybody's got a different way of contacting each other. For example, myself, I generally don't carry a cell phone. So if you're going to say, give me your phone, I'll text you, I'm just going to say, I don't do it. But I know I'm an odd man. Most people probably do use a phone. Some people may not want to do email at all. You need to figure out whether you and your teammate are what you're going to use, okay? Life goes on, whether or not school is in session. And so that includes getting married, getting sick, going to job interviews and stuff like that. So that has to be included. And you need to recognize that in any given semester, things will come up. And so you need to come to some agreement about how we're going to deal with these sort of things. Okay? If you have an emergency during the semester, mom's sick in the hospital, I gotta leave, I can't make the lab this week. Several people need to be notified. First and foremost, you need to talk to your teammate about it, okay? And figure out how we were going to work things out. Second thing is talk to your TA, make sure they know about it. And it wouldn't hurt to tell me also. Okay? We want to try to make some adjustments in the grading. We don't want to have a TA come and say, what's your name? Kevin. Kevin didn't show up today. Kevin didn't show up today. 0 for work. Well, if he had just told me his mother died, I'd probably be a little bit more sympathetic. Your mother died, if your dog died, if your cat died, I'm not sympathetic. I'm not a cat person. But dogs I love. Okay? A word about teamwork. It kind of goes with marriage. Marriage is not a 50-50 proposition, and teamwork is not a 50-50 proposition. It's 100%, 100%. It works best if I know I'm not a good programmer. I can do it. If I'm forced to, I'm usually by the end of the day, if I'm programming, my head hurts. But as part of a team, I will try to learn what my computer engineering partner is doing. Because next week he may be absent, and our team still needs to make progress. I know I'm a computer engineer, and I don't remember op-amps too well, but at least I'll try to get my teammate to explain what's going on, because I know he's got a job interview, and maybe I can at least kind of wire things together and make some measurements. Okay? And maybe we run into situations where neither one of us is good at particular item Z, so we need to figure out by hook or crook some way to get the information. Whether it's to look over the shoulder of an individual at another table and have a dialogue, or going to find some computer engineering professor, or taking the TA out to lunch. All right. So talk to your teammates about how you want to tackle this thing. There are a few weeks where Monday lectures aren't going to work. Labor Day falls on a Monday. We will not have a Labor Day lecture then. But there has been a presentation already done by Professor Nelson, Professor Emeritus Nelson. So if you go to Panopto recordings, you'll see several recordings. I think we have a total of 4 of them. This slide shows 2 of them. But I think we have recordings available for the first 4 weeks. I recommend that you want to take a look at Lab 1. That's this week. There were a lot of semesters where the semester does not start on a Monday, but we had lab anyway. Well, it's because the first week lab is not that difficult, so we have a Lab 1 presentation that you can take a look at. But more importantly, you do need to take a look at Lab 3, because that's the week of Labor Day. Okay, so that's kind of an overview of the course. Let me get back to, get out of this presentation and talk a little bit about what you see in the Canvas course. So this is, they say I'm currently logged into student view. I hope this is what you see when you are logged into the course. And so this is the home of the Canvas course. And so you'll see that there's a chart there. And the chart is kind of arranged in the first column. It's what week are we in? Okay, so we're in week 1. And with every week is associated a module of information. So the information in this course is a little bit different. The way we deliver it this semester is a little bit different than how we did it in past semesters. In past semesters, we had a website. People had to go to the website and find it. Okay. Here, this semester, I'm trying to get everything into Canvas, and so I'm organizing all the material into little boxes called modules. The topic or the Monday date is in the second column. That will be the date of the meeting. Today's August 19th. The title, it's an introduction to the course. In lab, you're going to do an introduction to the embedded software development environment. And over here in the far right-hand corner is submissions. What is due that week? Okay, so I tried to get the date correct. It says on the 23rd, which is Friday, everybody needs to do memo 0. Okay. If you're not sure if you're supposed to do it, you just click on that link. It'll tell you what the assignment is. Now, I think I'm going to like the memo modules. I hope you will too, because it helps organize everything you need for that week into one place. So if you click on module 1, we'll go to a new page, and there's a bunch of modules. So I've got 6 of the modules up right now. I'm going to go ahead and close them for right now. There's module 1, module 2, module 3, 4, 5, and 6. Those are, for the most part, are done. All the materials you need for that particular week are done. If I expand it, there's all the information that we need. And so we have covered the lab overview. That's the very first item. It's a PDF file. You can take a look at it. The next thing below it says Lab 1 project creation and debugging. This is really what you're going to do in lab. So click on that, take a look at it. You'll see below it some things that may be related to it. So you see it says ELEC30XO Lab 1 C program. We're going to provide you the C program this week. You don't have to remember anything about C programming. Well, you probably should try to remember some things, but you don't have to actually create one for lab this week. And so it's associated with the assignment, so I put it underneath the assignment and kind of indented it a little bit. There's some other information that will be useful because it's referenced in the presentation, and I've also included all that information. For example, like if necessary, if you wanted to install the development environment, it's called installing NDK ARM. Okay? If you wanted to learn how to debug your board, I reference it in the description above, but how much do you need to really read in depth that week? That's a decision you need to make. So all these items below, you see them further indented in. It's because they're kind of related to the assignment up at the top. So all the information that I believe you will need this week is put together. So you see there's a lot of reading to do because that's part of the written and oral communication skill that we want to demonstrate, is that we can absorb a lot of information as needed to get the job done. There's an assignment here called lab prep work. You see there's 8 points there. You can click on it and you'll find out what lab prep work is. Basically, it's just a reminder that the TA is going to make some sort of grade there. How is he going to grade me? Well, I put a little file here. It's called Lab Grading Rubrics, Lab Notebook Grading Rubrics. That file actually has several tables in it that tell us how the TAs kind of look at our work. So if I go ahead and open it, you get a preview here of some things. And so this is a rubric. So table A is a rubric for grading the notebooks. Table B is grading the actual in-lab performance. So you can take a look at that and get an idea of what is the expectation in lab. Let me see if I can get back to the module. Okay. I said, here's another assignment. Memo 0 is due August 23rd, Friday. Everybody needs to turn one in. And see, associated with it, there's some material that's been indented slightly to the right, some examples, the rubric that will be used for grading the memo. Okay, you want to know how do I score the most points? Okay. There's no lab notebook this week that needs to be turned in, but I put up the lab notebook grading rubric up there again, simply because you may want to be looking ahead, because there will be a place where you need to turn in a notebook for evaluation. And then there's some additional things related to assignments. This particular week in your memo, you're going to talk a little bit about what happened in lab, but there's also a auxiliary assignment. I ask you to take a look at the IEEE Code of Ethics and kind of give me a brief summary of what you learned from that. And you say, what is the IEEE Code of Ethics? Well, there's a place where you can find it in your module. Okay. Let me go back to home and go back again to this table. I recommend that you visit this regularly. It tells you what is going to happen that week. So for example, this week it tells us we're going to be introduced to how we load up a C program, compile it, debug it, and use our discovery board. And we got to study a little bit of a thing called the IEEE Code of Ethics. That's a link there you can get. And here's a memo. And then, so each week you can take a look and say, okay, do I need to write a memo or not? All right. Let me explain a little bit about memos. You'll see that the memo 0 is just called memo 0 because it's not going to be graded. You'll get some feedback, but it's not graded. But all the other memos are called A1, A2, B1, B2. A and B refer to the teammate. Okay, so you're either an A or you're a B. You and your teammates together form A and B. So if you take a look at the numbering there, you're going to see that there's a memo A1 and there's a memo A2. So if you're teammate A, you're going to write 2 memos this semester representing your team's progress. And your teammate is going to write memo B1 and memo B2. Okay, so you can see if you're the A guy, you're going to turn in a memo August 30th, and your next memo is not due until September 27th. Okay, so the memo is kind of spaced out Notebooks. Notebooks, everybody turns in notebooks. You notice that there's no dates, it just says in lab. So at the end of lab that week, if your notebook is going to get graded, you turn it over to your TA and he'll grade it and get it back to you Monday. Okay, so some weeks you turn in a notebook, some weeks you might turn in a memo, or your partner might turn in a memo. Let me say this about memos. From the memo, I also get a progress. I infer a progress grade. I read the memo, grade basically for grammar, clear communication, see whether or not you did the ethics case study assignment. There's several case study assignments. You see them highlighted here. IEEE Code of Ethics, Apple versus the FBI, the Tesla crash, the Volkswagen emissions, no servable parts. These are all ethics case studies. They go along with memos. So if you're doing a memo that week, you're going to talk not only about the progress in lab, but you're also going to do write a little something associated with that case study. It's not a ton of writing, but it's a little brief exercise. So I'll read the memo, evaluate the grammar and stuff like that, see the communication is good, and you'll get a grade. You, the author, will get a grade. I'll also read the memo and see who your teammate is, and I'll give both of you a progress grade. Both people will get a progress grade. One person gets a writing grade. Okay? And so both of you will get a progress grade. So I'm going to read this and I say, yeah, it looks like they're making pretty good progress. They get 4 out of 4. Okay? So what that means is even if you're not writing a memo that week, you might want to look over your partner's shoulder and say, hey, that's not a bad memo, but don't forget, we got this done. Okay? Because he maybe forgot that you got something done, and you want to make sure that he remembers to put it in the memo so that both of you get the maximum credit possible for your progress. Okay, so I encourage you to look through the Canvas page and see how the information is organized. Let me know if there's any improvements that we can make. Now, in lab this week, you're going to meet your TA. You will be issued your team will be issued a box. The TA will tell you about how to handle the box. You'll open up the box and you're going to spend a little bit of time this week learning how to use this breadboard system. This is the so-called Electronics Explorer. Yeah, Electronics Explorer EE board. So it looks like a breadboard on top with a bunch of other holes that do other things, because underneath here there's electronics that turn this board into a test instrument. There's a lot of interesting, useful electronic instruments on this board. There's signal generators, power supplies, logic analyzers, oscilloscopes, voltmeters, so on and so forth. And so we'll learn to use some of those instruments in the context of this course. You will also be issued, you will be loaned for a couple weeks one of these discovery boards. Okay, so it's the screen board. It's got a couple of microcontrollers on it. This is the one that's doing all the work. This is the one that's communicating to your PC through a cable, through a USB cable. Please go to the Canvas webpage to find out about this discovery board. There are a lot of discovery boards out there of different models and makes. Get the correct one, and then you need to go to what's the recommended vendor right now? DigiKey? Mauser? You went to DigiKey?
I use DigiKey.
Okay, so there's no textbook to buy, but you do need to buy one of these. And I think the lightest cost was
It's like $7.
$7.
The shipping costs more than it does to buy the board.
Yeah, the shipping costs more than it takes to buy the board. So maybe you and your partner both order together and do something like that. We ask that you buy the board. We have found that we usually get a better lab experience overall when you have a vested interest in keeping that board alive. So you'll go into lab, you're going to be introduced to the discovery board. You'll be introduced to the EE board. You'll follow some instructions about how to piece it all together, We provide you with a C program. It's in the module. You'll learn to go through the steps of loading it, compiling it, debugging it, loading it onto this thing, make some observations, and say, when you walk out this week, you say, okay, I got an introduction into using this development environment that I will use for the rest of the semester. Okay? So that's the goal this week. Any questions? Any thoughts? TAs? Graham?
If you are the one person in the single group, you need to make sure you know how to program. That's really important.
Yeah, so there is, like we said, a lone wolf out there. The lab is not impossible, the course is not impossible to do alone. We will make great adjustments, but as Graham said, you will be doing some programming.